Okay, so here we have derivation 2.6 LRS 6. So we'll show the conclusion. The conclusion is a biconditional, so we're going to show both conditionals. Right, this here is the main connective. So we're going to show a conditional, so we're going to assume the antecedent. Let's go ahead and split that antecedent up. And now we'll show the consequent. Actually, no. We're going to split it up later. We'll assume the consequent, assume the antecedent, show the consequent, and make an indirect assumption. And now we'll split 3 up down here. So it shows up down here, and we'll bring 5 down as well. So what we really care about at this point is 7, 8, 9, and 10. 3 and 5 we've moved. Okay, so we have if not Q then R, if not R then not Q, Q or not R, and not Q or not R. What should we do? Well, again, there's no show unneg to be done. We're stuck, right? It's not our fault, it's the derivation's fault. So we need to do a subderivation. No show unneg to be done, so we want to do either show antecedent or show neg disjunct or show neg cons. So let's go ahead and say show ant of, 7. And we'll make an indirect assumption. This is going to be useful. Actually, this is not the version we want. We want the double negated version. So let's bring that one in. Why did we want the double negated version? Because we're going to be able to use it with both with here and with here. We're going to do MT with line 8 and MTP with line 10, and we need the double negation for both. So we'll say 8, 12 MT, and we'll say 10, 12 MTP. And look, we have a contradiction because we get not R from here, and we get not R from there. So that's an indirect derivation. Now we need to use not Q, so we can use it with line 7. And we get R. Now, what are we going to do now? Well, we can use not Q again. Even though we didn't derive it for this reason, we can use not Q with line 9. So we can say 9, 11 MTP. This is another example of how when you do a subderivation of a line of a sentence, you might use it in multiple ways. In the previous derivation, we used it both to break up a larger sentence, and we broke it up here. We're using the thing we showed to break up multiple other sentences, and so that's again something you want to be on the lookout for. When you use, typically so far when you complete a subderivation, you use the thing you did a subderivation of once and you're done with it. But as derivations get more complicated, that's not always the case. So if you do a subderivation and you find yourself getting stuck, check and see if the line you did the subderivation, the subderivation that you completed, see if you can use it in more than one way. Okay, so this is 6 is the consequent of 4, and 4 is the consequent of 2. So that's half of the derivation. Let's look at the other half. So again, it's conditional, so we'll assume it's consequent. We're going to show the consequent. Now, in this case, we're trying to show a conjunction, so we want to show each conjunct. So we'll go ahead and show this conjunct. So we want to show if not R, then not Q. So we'll assume the antecedent, show the consequent, and make an indirect assumption. Okay, now we need to think about what to do. So we look at line 22, and can we use line 22? Which is not, if not Q or not R, then it's not the case that not Q only if R. Indeed, we can. Well, so we want to get either the antecedent or the negation of the consequent, and we can actually get either of those. The easier one is to get is the antecedent, because we can use line 25, and we can put not Q on the left of that not R, and we get not Q or not R, which is the antecedent of 22. You could do a show on negation with line 29. The easier thing to do is apply the derived rule NC. I don't recall off the top of my head which theorem it is, but it's in that list of good derived rules. And this is nice because now we have whereas with 29 we had a negated conditional, now we have a conjunction, and we can split off the left conjunct, and we have a contradiction between 27 and 31. Oops, and let's say it's an contradiction. So 26 is the consequent of 24. 24 is one of the two conjuncts of 23, so now we'll show the other conjunct. No, we won't. We'll try to show the other conjunct, and if we can get that show line set up, that'll be good. Okay, so not, so Q or not R, so we can assume ID, we can apply De Morgan's. Not Q and also not R. Okay, so same strategy. We can break off the not Q and add not R to it on the right. That's the antecedent in line 22. And again, we can apply the rule NC, and we can break off the right side of 40 and the right side of 36. And there we have an indirect derivation. So we have our two conjuncts. We will add them, join them, and we will get the consequent that we want. And that's, oops, no, that's a direct derivation. 23 is the consequent of line 21. So we'll put these two together, and we'll get the conclusion. So there's that derivation. So I hope that was helpful. If you have questions about any of the homework problems, please let me know.